2020. My name is Kyle Waldron, and I am on the board of the Sustainable Remediation Forum. Today we have a great presentation for you. We have Rob Rebel of LT Environmental. He's going to do a presentation on the use of sustainable solar-powered soil vapor extraction. And so for those of you who do not know SURF, SURF is a nonprofit organization that's made up of government, industry, consultants, and academia representatives. We have a technical component where we have sessions at the AEHS conference. We do these webinars. We have case studies, libraries of case studies on our website, and a number of publications, white papers, that type of thing. And you can find more information on SURF on the website, and feel free to join the email list and get updates as new things come out. And with that, I will welcome Rob Rebel. And if you guys have questions throughout the presentation, feel free to use the chat function, send them directly to the host, Sustainable Remediation Forum, or Rob Rebel directly. And we'll get to them at the end. Thank you. And welcome, Rob. Thank you.
Great. Thanks, Kyle. Can you hear me clearly?
Yes.
Okay, great. To those new to SURF, welcome. And today we'll talk about a new way to view your sites through the lens of sustainability. Expose you to tools so you can begin to quantify your sites, which will allow you to bring metrics to the decision-making process. For those current SURF members and participants, I truly appreciate all the content that I've been exposed to the last couple of years. It changes how I present information to my clients and stakeholders. And two of the previous webinars, for those who haven't watched them, there was one that highlighted SITEWISET, which is a way to get some sustainability metrics. And there was another one that reviewed the social side of sustainability and how to navigate that complex social side of picking our remediation strategies. So this webinar will help tie those concepts to a real-world site and arm you with another case study on sustainable remediation. So when we talk sustainability, this Venn diagram is often shown. So what is it? A lot of times they say it's three pillars: people, planet, profits. So it's the intersection of these three: people, social aspect, profits, economic, and planet, environment. And when all three of these are considered and weighted, you arrive at the middle of sustainability and have a truly sustainable solution. So this is a schematic showing the same Venn diagram pulled from the ITRC Green and Sustainable Remediation and Practical Framework. And it shows that in theory, all three of these would be weighted evenly, with each sharing the equal weighting to realize sustainability. At present, however, the environmental aspects, the green remediation side of things, really holds a higher weighting. And so there is room for growth in both the social and economic realms. And so looking at it the other day, I couldn't help but think about this from a consultant's perspective and my own inherent biases and perspective pre-SURF. So one of the strengths of SURF is that it does include members of consulting, industry, regulatory agencies, and academia. And I believe we all occupy a different side of this Venn diagram, with, of course, the exception of academia, which is unbiased. But I feel like because we do occupy a different sides, we have some inherent biases. So as a consultant for 15 years, my main metrics to clients have been: will the technology clean up a site, the environmental, and how much will it cost, economic. So having me reside on the right side of the diagram. Regulatory agencies, their responsibility is to protect the environment and the health of the community. So they reside via the environmental social left side. And then people in industry, they strive to be good stewards in their communities they operate in and where their employees live. And believe it or not, they have budgets that they have to operate under. And even large companies have limited resources. So they are in the bottom of the Venn diagram. So when all these stakeholders meet, typically the consultant provides metrics, and often it does include much of the social aspect. But in my post-SURF experience, now other stakeholders at the tables, their ears start to perk up when the discussion mentions number of truck trips leading to dust and road degradation, a social metric rather than this technology is more feasible than the other. So, for economic metrics, industry is reluctant to talk money in fear of this misperception that technology is chosen because it's cheap, even when the technology is better social metrics. And in reality, if we start comparing social and economic metrics, sometimes with higher economic metrics, you have more resources, so higher greenhouse gas footprint, and which can be better for society as a whole to have a lower footprint if you have lower economics. And so ultimately, I believe to grow the social and economic metrics, we need more diverse exposure to SURF, help us remove our biases and stigmas based on our roles, and we need the education on tools available. I hope this case study is another link in the chain, moving us towards a sweet spot of sustainable remediation. So first, we're going to go through some site background and remediation, then dive into the sustainability metrics once we have the scenario laid out. Typically for this site, and we did for this site have sustainable metrics at the decision-making process. So you'd be incorporated into your site conceptual model from the beginning and then updated as you proceed throughout the project. Now that this is near the end of the project, we expanded the metrics for this case study and educational purposes. So shown here is a old historic oil and gas production pit. It's operational since the late 70s. Typically in an oil and gas field, you have oil and gas coming to the surface, but also have a byproduct to produce water. So typically these pits are used to put produced water in where they allow it to volatilize. And also, of course, it seeps into the subsurface. There also is a gas compressor on site, so there's likely some natural gas condensate that dropped out that was also put into these pits. There's multiple pits in this field require remediation via the regulatory authority, COGCC, and these are very remote locations. So shown here on the left is a aerial photo of this. This is about as remote as it gets. It's 2 hours south of Rock Springs, Wyoming, and 2 hours north of Meade, Colorado. So canyon country, it is primarily BLM land, and primarily the only infrastructure is oil and gas fields, so compressor stations and well pads. And with that brings a lot of site challenges. No power infrastructure to operate a mechanical system. The closest landfill is 2 hours away. We have multiple pits that need remediation. We have relatively high concentration of petroleum hydrocarbons. So monitor natural attenuation is likely not going to occur here in a short time frame. And typically with these sites, the industry will do dig and haul. And from a qualitative perspective, it's pretty easy for us to see that dig and haul is not sustainable. We will start to tie metrics into this to show how it is quantitatively not sustainable, but qualitatively the waste is moved and not remediated. You have increased landfill waste, long truck trips leading to increased greenhouse gas emissions. It's expensive hiring all that heavy equipment. And then there also is a social aspect. You have more trucks on the road, causing safety concerns, dust, noise, odor, etc. And so here's a picture of our pit. We're dealing with the one in the south circled in red. That's our approximate extent of impact. You can also see to the north, there is another pit present right here, which is part of the program. And so we have 2,500 cubic yards of impacted soil. Our contaminants of concern are total petroleum hydrocarbons, gasoline, and diesel range organics, and BTEX. So 60 feet by 40 feet by 30 feet deep. So there is no power on site due to it being unsaturated in the geology. SVE or excavation are our two best fit technologies. So SVE, soil vapor extraction, you put wells into the impacted area, either horizontal or vertical, apply vacuum to those wells, which induces air to travel through the subsurface. As that air passes over impacted soil, those petroleum hydrocarbons volatilize and then are removed. As a secondary benefit, you are also increasing oxygen in the subsurface, so you have some more aerobic microbial degradation of your contaminants. So this is a 3D geologic model of the site. Of course, it is not homogeneous material. We have heterogeneities out here. We have a Brown's clay, the very bottom, the dark Brown's clay stone, silts, and we have sands present. So initially, we designed 4 SVE wells, and we installed these during mobilization for another pit during this assessment. You know, as you start crunching numbers, you start to realize that every trip you take to a site has its own environmental footprint via energy use, via greenhouse gas emissions, and also other criteria pollutants. So to ensure that we had good even distribution of airflow, we decided to conduct a pilot test to test how this clay sand affected one another. So in the middle, we'll see this is one of our pilot test wells, or SVE wells. The red is the staining, and next to that is our photoionization detector PID response. And this is set in clay and silt in the top of the clay stone. So we applied a vac truck to each of the 4 wells and measured response. The wells were screened in clay, could influence the clay and the sand, but the wells screened in sand can only influence sand. It's because the clay requires a higher vacuum to induce airflow. So that higher vacuum could propagate throughout the subsurface in both the finer grain and coarser grain material. But when you're applying vacuum to the sand, it would not influence the clay. So we installed 2 additional wells, 6 wells total, installed into shallow impact and also into the clay to ensure flow throughout the site. So without a power drop, how are we going to do SVE? And that's where sustainable technologies, their very sun mobile solar system out of Alameda, California, come in. So this system can operate with or without a power drop. It operates a 5 horsepower regenerative blower right here, capable of 170 CFM at 50 inches water column. So one thing unique to these systems is it is direct drive from the solar to the 3-phase blower via the very sun solar control system. So typically with solar systems, you have an intermediary between your solar panels and your equipment. So you would have batteries or a grid-tied system. So you'd be putting your power into the grid or into the batteries and operating your blower or your equipment off of the grid or the batteries, vice versa. So pretty unique in terms of it streamlines that process. And we provide power via 6 kilowatt array, 20 panels. So they use a pod approach here, so can be scaled up or down. And the 5 horsepower motor can actually operate off of one of these pods, 10 panels, so 3 kilowatts. But we determined, since there was multiple pits, it'd be worth extra investment to increase our operational runtime. So the sun comes up in the morning, the system starts running, and then as it sets, it will shut down. But with more panels, we'll reach our high RPMs sooner because we have more power available. On the right picture, we have a 40-gallon knockout tank here to collect any condensation or water that we pool. There's an adjustable manifold where we can measure flow, and we can measure vacuum, and also collect PID readings. So we can tell how hard we're pulling from each well, how much airflow, what our volatiles are, so we can start to maximize our mass removal. And then we also use above ground HDPE for ease of installation and cost reduction. So one great thing about these systems is they're very transportable. The top and the bottom panels fold down, so it can fit on a semi-trailer that is not oversized. And then they're easy to move with a loader. And then you put these on precast concrete blocks, 2 for each pod, 7 feet by 3 feet by 10 inches thick. And this is pretty fast installation. Me and one of our construction managers, Eric Baum, we literally installed this in less than a day. We leveled the ground, received the precast blocks, unloaded the solar panels, anchored them to the precast blocks, unfolded the panels, did the final electrical, hooked up the piping, and we're running by the end of the day. Equipment costs about $70K. This is pre-solar tariff, so you definitely would want to get a revised quote. But if costs are prohibitive, rentals are also available. via sustainable technologies. So this is a graph of our air emissions to date. The pink is our cumulative total volatile petroleum hydrocarbons in tons, and the blue is our stack concentration. And so you can see we had very high concentrations to start. We had to do some bypass air to ensure that we had our air permits in place before we exceeded a 2-ton threshold. And then once we closed the bypass, we saw an increase. And then I'll get into some other expansion that we did in October and January 2020. But samples on a monthly basis and removed 7 tons over 2.5 years. And so in 2018, we did some soil sampling to see where we were in remediation, and the southwest area of the site went into compliance. We did install an additional SVE well, SVE-07. There was some shallow soil that was not previously identified that we addressed. And we shut off 2 of the SVE wells. And we always anticipated a 2 to 3 remediation timeframe period. So this is about what we expected to see. In November 2019, we conducted the next round of soil sampling, and we have remediated all of our shallow impact. The only remaining impact is deep impact in SB 2, 3, and 4. And so while we're out there, we brought well materials with us in case we saw impact at depth. You know, those well materials, as we'll see later, do have a footprint associated with them, but also does the mobilization. So does preventing a mobilization outweigh well materials? In our case, yes, that is the case since we're so remote. So we went ahead and installed the wells. We wound up utilizing 3 of those wells, the ones in 2, 3, and 4 area, and we still are using existing SVE-02. So we will sample again in 2020 for closure. And so just a little more on this SVE operations. If you are measuring your stack concentrations and you see asymptotic levels are starting to level out, you need to do something. You need to either sample for compliance or you need to do some operational changes. So here is where we did our first expansion. You see a slight uptick. This is likely due to freezing pipes in winter, due to condensation buildup, unfreezing, and then now that we did the new expansion pulling from the deeper zones, you can see this sharp increase. Last night we did receive our next air sample, and we are right here. So I imagine we'll start seeing a decline, continue to optimize, and then once we reach asymptotic conditions down here, it'll be time to sample. And a lot of times, if you're doing performance sampling, it's worth bringing supplies out to install wells to prevent that additional mobilization. So now that we have our scenario out there, we have dig and haul and solar SVE, we're going to start making it quantitative. And so here are a couple tools that are listed on the SURF website. And these are 3 that I've utilized. There are more available out there, and some even being proprietary programs. All these listed here are free. SITEWISET was developed by the U.S. Army Corps of Engineers, the United States Navy, and Battelle. The greenhouse gas protocol is also free, and it is not as tailored to the environmental industry. So it's more appropriate for municipalities or a company trying to figure out the greenhouse gas footprint, because it doesn't get into some of the intricacies that the SITEWISET program has. So another tool is EPA's green remediation, and you can see there, this is the core elements. So energy, air, water, land and ecosystems, material waste, stewardship. You can certainly put metrics to this, which we did in the past. And EPA also has their own spreadsheet for calculating CEFA, spreadsheets for environmental footprint analysis. And one, any of these, no program has become the industry standard, and everyone has a preference. But in reality, any analysis is better than no analysis, as long as it's unbiased, can be repeated, and utilizes some industry standard metrics, such as these. And one important measure that garners attention for good reason is greenhouse gas footprint. So for greenhouse gas footprint, so we're all talking the same vernacular, we use metric ton CO2 equivalents. And we use this because CO2 is the most common greenhouse gas emitted by human activities in terms of quantity and total impact. But we also have different contributors that last for different lengths of time and absorb different amounts of heat. So the Kyoto gases include carbon dioxide, methane, nitrous oxide, hydrofluorocarbons, perfluorocarbons, sulfur hexafluoride, and nitrogen trifluoride. And for example, methane has 25 times more warming over a 100-year period than CO2. So 1 metric ton of methane is 25 metric ton CO2 equivalents. And sulfur hexafluoride has the largest global warming potential at 22,800 times the potential of CO2. So we convert all these to CO2 equivalents so we can talk apples to apples. And so when you download the SITEWISE, it's a zip file. It's a series of 8 Excel worksheets in a user guide. But don't fret, this looks intimidating, but the worksheets use macros and it automates a lot of the processes behind the scenes. So you only input into one spreadsheet, SITEWISE input sheet. You have one summary sheet, the final summary sheet. So SITEWISE is designed and really tailored to the environmental footprint and remedial alternatives generally used within the industry. Quantifiable metrics such as greenhouse gas, energy use, electricity use, criteria, air pollutants, water usage, resource consumption, etc. And it utilizes a block approach. You'll see this components 1, 2, 3, 4. That is so you can start slicing out different phases of your site or slicing different technologies in different scenarios. It really makes it pretty flexible to optimize for each technology. And here is on the right, this is one of the input sheets. This is material production. So you can see we have well materials. We have 8 wells as SVE wells. Average depth, they're made with PVC. We have sand, gravel, bentonite, cement. You know, all these have a footprint associated with them, especially cement and PVC. They're high energy materials. There's a place for treatment chemical materials if you do injection technologies. Construction materials, we have precast concrete blocks that have a footprint associated with them. And then well decommissioning, we'll have to decommission these SVE wells. So there's a footprint associated with that. Other areas are transportation. So having O&M techs go on a monthly basis to the site, drill rigs drive and mobilize out there, that has a footprint. Equipment use. So if earthwork for dig and haul, for your excavators, or our motors for our equipment, residual handling, hauling waste to the landfill, and also what's going to happen to the waste when it's in a landfill. You know, that has methane or other associations with it. Resource consumption, topsoil, water. And then they also have ways to get credits, so footprint reduction for solar credits or wind credits or renewable energy certificates. And if you have yet to dive into SITEWISE, or even if you have dabbled a little bit, I'd highly recommend watching the July webinar, Introduction to SITEWISE by Jason McNew, who is the SURF treasurer and from EA Engineering, Science, and Technology. He really delves into the intricacies, how to save file, create new scenario. He walks through a pretty simple scenario of nested wells versus non-nested wells and what the different footprint is and what the reduction is between the two. So it's an hour-long webinar, but it'll save you far more than an hour's worth of time watching it. And so one factor I didn't really expect from SITEWISE are safety metrics. This is the accident risk injury for dig and haul and solar SVE, and you can clearly see that dig and haul has a higher accident risk associated with it. Part of this is you can choose what type of labor you'll have out there, mainly construction laborers for dig and haul, versus scientific and technical services for more of a solar SVE. It is worth noting, though, that SITEWISE does have standardization. So even though dig and haul does have a higher accident risk, these are both rated as low in the SITEWISE output. And as I mentioned, there are solar power credits that you can get. This is the solar power, and you can start to see the renewable energy certificates input. And one problem is they have not accounted or a system like sustainable technologies. They assume that you're going to be grid tied in. And so there's input for how much power comes from your photovoltaics. And when I plug in 100% for photovoltaics, my greenhouse gas footprint goes to negative. But we all know that that's not the case. Solar panels, the materials have to be mined, they have to be manufactured. One industry metric that's commonly out there is 0.1 pound CO2 equivalents per kilowatt hour. That accounts for both of those activities. So previously, we estimated 2.3 metric ton CO2 equivalents from use of solar panels. And for these metric calculations, since it couldn't account for that and started going negative, we just didn't account for the power source. So the blower electricity and the photovoltaics credits and the power for the motor were not utilized so that it wouldn't bias our results. And so this is one of the outputs from SITEWISE. These are the raw numbers. And so you can see dig and haul greenhouse gas emissions, 152 metric ton CO2 equivalents versus 16 for solar. Total energy use, water consumption, electricity use, our on-site air quality, so NOx, SOx, PM10, and then total NOx, SOx, and PM10. And then we also have our accident risk and for both fatality and injury. And so an easier way to read this is the qualitative. So red, stop, high risk, green, go, low risk. And you can see through this that on almost all categories, dig and haul has a pretty high footprint, where solar SVE only has one high footprint, that's energy use. So we are making monthly trips to the site. We do have 4 drill rig events, and those definitely expend a lot of energy. And so it's represented here. One thing that is nice about the SITEWISE is that it does give you this relative qualitative analysis. So 152 metric tons CO2 equivalents is high greenhouse gas emissions for remediation, but 16 is low. So it's nice to have these ranges that are industry specific so we can tell how our footprint is relative to others in the industry. Another note here is the far bottom right, the community impacts and resources lost. These are user entered data, and so it does not quantify these metrics. But due to dig and haul having dust and noise, that community impact was medium, and resources lost, we removed that topsoil. We judged that medium as well. However, we will get into social metrics in some later slides. Another great SITEWISE output is this normalized impact. So it takes the highest number and normalizes it to 1, and then you can see relatively how it compares to the other option. Dig and haul in blue far outweighs in almost every category except for total energy use compared to solar SVE. So environmentally, we have a much larger footprint for dig and haul versus solar. One thing of note is our greenhouse gas emissions. So previously for this site, in the initial phases, we utilized greenhouse gas protocol to calculate emissions. And from that, I calculated 79 metric ton CO2 equivalents for the dig and haul versus 9.3 for CO2. So we underreported by 70 to 90%. And part of that is because SITEWISE is tailored for remediation. So it accounted for my well materials from my solar SVE. It accounted better for waste disposition in the landfill. Accounted for round trips versus just single hauling trips to the landfill. So it's something that, as our industry doesn't really have a standard method, it's something to think about, that there are different ways of doing it with different results. So as we compare different technologies, we just need to be consistent with what method we use. And so now on to social metrics, which is complex. The December SURF webinar, the social side of sustainability, Melissa Harklerode from CDM Smith did an excellent job talking about how to navigate these complexities. So she went through the ITRC, green sustainable remediation, stakeholder involvement, and how to update your site conceptual model. So who are your stakeholders? What are the relationships between them all and the responsible party? What relation are the relationships good, bad? Do they need to be mended? And also how to get their participation in the process, how to bring it into your conceptual side model and continue to update it, get them information that they need to make decisions. And from that, she then goes into grabbing metrics from the SURF white paper, integrating the social dimension in remediation. And they use 10 main societal impact categories. So you look at those 10 main societal impact categories, which I'll show in the next couple slides. And those, you pick which ones apply and then provide metrics for each one. And then the third version, which we will go through, the Social Sustainability Evaluation Metrics, SSEM, developed by Dr. Krishna Reddy from the University of Illinois Chicago. He breaks it down into multiple components: a social individual, social institutional, socioeconomic, and social environmental. And we'll go through some intricacies of SSEM and give the output for the site. So whenever talking social, you need to think about who are your stakeholders. What is their identity and what are their concerns? And so for us, we have the regulatory authority, the COGCC, the Colorado Oil and Gas Conservation Commission, and their statement, mission statement, is to protect public health, safety, welfare, the environment, and wildlife resources. We also have the U.S. Bureau of Land Management. Talking to them, they wanted us to remain on the existing disturbance footprint as much as possible, and if we're going solar, to prevent birds from roosting on the solar panels. And adjacent landowners plus resident, the closest landowner is 9 miles away. So there are no close residences, and I believe that's the only one before you reach the outskirts of Rock Springs. And we did not contact this residence, but if we did decide excavation, dig, and haul was the route, we can surmise what that residence might say is 100 to 200 trucks are driving past the residence. And then the community of Rock Springs, where the waste would be hauled, it would fill up the landfill some, but it could also employ truck drivers. And so these are the 10 main societal impact categories from that paper mentioned earlier. And I've highlighted, bolded the ones that would apply to this site. So health and safety, we have trucks on roadway, worker safety, economic vitality, there would be employment for truck drivers, and then alleviate undesirable community impact. So these both would be active remediation versus do nothing approach. But we'd have dust, noise, increased landfill waste, and then regional and global societal impacts, greenhouse gas footprint. We can certainly put metrics to all of these and present them to the stakeholders. So the other tool that we'll dive into more in depth is this social sustainability evaluation metrics. So on the right, you'll see this is one of the categories, socioeconomic, and there's 11 key measures. For the other categories, there's 18 key measures for social individual, 18 for social institutional, 13 for social environmental. And so some of these categories in socioeconomic include disruption of businesses, employment opportunities, disadvantaged business entities investments. So these categories include both negative consequences, which we typically think of at least when I think of social, that's what comes to mind. But what's underrated is the positive outcomes that come from remedial action. There are economic stimuluses from our remediation. And so then these categories are made quantifiable. By the upper left, you'll see the scoring system based on positive or negative impact. So ideal positive impact 2, negative, unacceptable negative impact -2. If it doesn't apply, it gives a neutral score. And so for this paper mentioned below, they evaluated 2 cases. And this is one of the graphs from one of the case studies. And it evaluated no remedy, in situ solidification stabilization, and dig and haul. And from this, you can see in situ solidification stabilization had a clear societal benefit compared to no remedy, while excavate and haul did have some benefits societally for increased business and economics, but the social environmental was ultimately negative. So for us and our site, we can clearly see that SVE in red has the best positive social sustainability. And one surprise for me is that dig and haul was actually neutral, and no remedy had no environmental footprint. So score positive for that, but the social, individual, institutional, and economic were all negative. So it has its social consequences. And I'm going to go through each option and highlight some of the factors to shed some light on how these rankings came about, expose you to some of these intricacies of the tool. So this is no remedy. And you'll see that my totals don't match. And so this is just because I'm not including all the metrics that I want to fit on a slide. So this is just a selection from some categories. For social and social institutional, if we did no remedy, it could change the perception of the public and trust of the regulatory authority. So UGTC could have a negative view of this and think the company doesn't clean up their impact, so that received a negative score. For economic, since there is no remedy, there is no economic activity, which is negative, but does have a positive score for a degree of disruption because we wouldn't have no disruption associated with no remedy. So the grand score ultimately was -6. For solar SVE, we wouldn't erode public trust as it is an active remedy, so it would have a positive perception. Socioeconomic, it would have employment opportunities, generate green and sustainable business via sustainable technologies in Alameda. Social environmental, there is some disruption from traffic, but the remediation would remediate the contaminants in situ. It is a green remediation, and it utilizes green energy via solar voltaics. And the degree proposed remediation will affect other media. That was given a negative score because we do have some VOCs that are generated from this technology and some emissions, and so that scored negative. For dig and haul, it would provide employment opportunities. It would stimulate the economy some of Rock Springs. There is some risk to workers for this thing, and there is a lot of disruption from noise, truck traffic, so that received negative too. The contaminants would be removed, but it's not green, and it will affect other media via the SOx, NOx, and other criteria pollutants. And all this led to a neutral score for dig and haul. So overall, you can see solar as the overall most beneficial societal impact, leads in each category. For this scenario, only a quarter of the metrics were used, which I believe is appropriate for the site setting and land use. I mean, we are not in an urban setting. We're pretty far away from the city. But the tool does cover those scenarios as well. And so just because I'm not in an urban center, those are scored neutral, versus if I was in an urban center, we would be using a lot more of the categories associated with them. Another strength of this tool is that the ranking system only utilizes -2 to 2. So you can only sway each category by 2 points one way or the other, which I think adds to the unbiased nature of it, and adds to the strength of the overall system. It's easy to fill out and interpret the results on something that I previously thought was almost impossible to fully quantify, both benefits and drawbacks to environmental remediation footprint. And I believe SSEM will start to become the standard when social metrics are required. And if you have a large project in an urban setting, then you should definitely look into SSEM, the Social Sustainability Evaluation Metrics. And so for, we've covered the environment via SITEWISET, and we've covered the social side via the SSEM. And so our other pillar are economics, our profits. And so traditional dig and haul estimate, $200,000. SVE total project budget including systems, $150,000. And we're also non-disruptive on-site operations and no loss of revenue via the operator. So already with this one system, we're $50,000 cheaper. But if we look at the life cycle of all the pits, it gets even a little more powerful. Dig and haul would be $60,000 versus $300,000 for solar SVE. So sustainability makes economic sense. And sustainability makes environmental sense. We've shown that through the SITEWISE. We have less waste generated, 2,500 cubic yards versus less than 5. Less greenhouse gases, 152 metric tons CO2 versus 16 metric tons CO2 equivalents. Less on-site and off-site NOx, SOx, and PM. And we have no loss of topsoil. And it makes social sense. SSEM showed that in a quantifiable way, but also, sitting down with the stakeholders, a relationship was developed with the CUGCC. And when we talked to them deciding dig and haul or solar SV, they considered other factors other than the fast cleanup. So they liked hearing about the remediation portfolio in respects to waste, disturbance, overall sustainability, and they allowed this alternative step-wide approach. And it really has created a positive perception by the CUGCC and has been an example to influence other responsible parties in the area to pursue similar green technologies. And so below is my contact information. If you want some support crunching sustainability metrics, please reach out to me. Ernesto from Sustainable Technologies, their info is on the right. Ernesto and his team build more than just solar SV2. So if your project has electrical demand, they'll have a solution for you. SURF is an amazing organization, people throughout the industry and even international. It's helping to push our industry to clean up contamination without creating more pollution in the process. For government employees listening today, it's free to join. And students, you will get discounts for students. You'll have access to library resources, and discounts for the AHS conference. And I really appreciate this opportunity to share this case study with you. Hope it's armed you with some tools to start reviewing your sites both qualitatively and, more importantly, quantitatively in a more sustainable way. Allow you to crunch numbers using industry accepted and unbiased methods so you can present these metrics so stakeholders can make the best decision for their community, the environment, and the bottom line. People, planet, profits. And now I'll turn it over to Kyle for some surf news, and then we'll follow up with some question and answers if we have any.
Thanks, Rob. That was fantastic. For additional information, I just sent out a link to a SurveyMonkey. If you want PDH credits, just fill that out. It's just a couple of questions with your contact info, and we'll send out something after the meeting. And then again, for more information on SURF, visit our website. And then we'll also be at the AHS conference in San Diego next month. There's an open surf meeting you can feel free to attend. And then there's also in the works, we're going to have a board meeting in April that will be open to all surf members to kind of hear, what's going on with the different technical initiatives and other things ongoing. If you missed some of this or you'd like to rewatch it, feel free to visit our YouTube page. It also has the previous webinars that some of which Rob mentioned in his talk. And then I will say, if you are interested in a more deeper dive on SiteWise, Jason will actually be at Mattel this year with Betsy Collins, who's the SURF Vice President, and they'll be doing a learning lab at that conference. So we do have a couple of upcoming webinars. It should be fantastic. We try to do them every couple months. So in April, we'll be doing one on the resilient remediation in Massachusetts. And then in June, there will be one from one of our sister chapters in the UK, doing it on a sustainable kind of remediation approach assessment that they have just drafted and come out with. So with that, I will thank our sponsors, which make SURF possible. And if you guys have any questions, feel free to submit them through the chat box, either to everyone, to me, or to Rob, and we'll answer those. And maybe while we wait for some people that have any questions, Rob, you can answer one or two of mine.
Okay.
So,
yeah.
I guess what kind of went into the decision regarding selecting a solar system that just runs when the sun's up versus, buying the battery and being able to run it 24/7?
So batteries are expensive and they have a huge footprint. And also, once you start utilizing them, I mean, we have a lot of systems out functioning now that do operate off of batteries, but these start to top out about 1 horsepower. Once you start getting in the 5 horsepower range, you're talking a pretty large battery bank. And also, infrastructure plays a big role here. There's no power drop out here. But there is a station about a mile away that has a natural gas generator, but there are no power resources. And so sustainable technologies really has kind of opened the field for a large blower to be able to operate off just solar panels. I mean, the batteries are expensive too. That's another factor. Economically, it makes a lot of sense if you have the time frame to go with a less expensive system that has less of environmental footprint overall.
And then maybe could you talk about the socio-economic piece where, maybe by doing a remedy, like a higher cost, higher energy remedy like dig and haul, maybe you're creating jobs for that project versus, the socio-economic impacts of potentially that money just going, the responsible party being able to use that money to invest in maybe like actual energy projects versus a remediation project. How is that kind of weighed and evaluated?
Yeah, I mean it's weighed somewhat. I mean the SSEM tool definitely accounts for that. It doesn't account for the corporation having more money to do other things, but it does account for economic stimuluses associated with the technology. So will it provide more jobs? Like, is there an O&M technician that will be going there every day? Are they hiring truck drivers? It is, difficult to quantify these things, but I think one example, I'll switch back to the slide that shows the case study. And when we weight all these, we can see that, excavate, even with some, it is positive mostly, dig and haul. For all these categories, the only place it starts to become negative is via this environmental aspect. So the associated footprint, the extra air emissions in the air, the dust, the odor, noise that's associated with it. So dig and haul, and really socially, most of the metrics pointed as a positive.
I guess that's what I'm getting at. Maybe a massive $100 million dig and haul project creates some short-term economic activity associated with that project versus, doing something lower cost, risk-based, and taking a portion of that money and the RP being able to invest in their own project and maybe a longer term, labor outlook. I don't know if that's true or not. Maybe they just profit it
Yeah, I
and
mean,
do other things, but
I guess that reiterates something that Melissa Harkleroad really states is that that's something that can be brought to the table when everybody's seated there. When you have all the stakeholders at the table, industry can start stating that, right? We can spend the money here and do this dig and haul project, or we can invest here and build this new facility, which will employ so many people. So each job has its specifics that are hard to quantify necessarily, but when you bring everybody together, these are the type of discussions that need to occur to reach the most socially sustainable solution.
oh, that's great. I don't see any questions. I don't know if you have any in your inbox, Rob.
No, I have some great presentation. That's all I see.
Okay. Well, with that, then, I appreciate everybody's time and I appreciate you presenting, Rob. It was great. Thank you. And we'll look forward to seeing hopefully some of you at AEHS next month. If not, stay tuned for some email notifications for the next webinar coming in April. So I appreciate it. Thank you, everybody.
Great, thanks.